Okay, student, good morning to all of you. Myself is Dr. Santosh Choudhury, a reader in chemistry. In last class, that in class number 7, we have discussed about some characteristics of phenol. And the characteristics of phenol, first the phenol acidic nature, because when the phenol dissolve in water, dissociate to form H plus ion in the phenoxide ion. The phenoxide ion can be stabilized by resonance. And the resonance structure of phenoxide ion compared to the resonance structure of phenol is more stable. That's why phenol dissociate to give phenoxide ion and H plus ion, that's why acidic in nature. On the other hand, the alcohol also possesses OH group, that's not acidic character because the alkoxide ion is unstable due to lack of the resonance. The acidic strength of the phenol depends upon the substituents in the benzene ring. When the benzene ring of the phenol substituted by the electron withdrawing group such as NO2 group, Br, Cl, the acidic strength of the phenol increases. Further, when substituents electron withdrawing group substituted para position is more acidic as compared to ortho position and meta position and then the phenol. On the other hand, when the benzene ring of the phenol substituted by electron donating group which can destabilize the phenoxide ion because OH group is giving the electron and this group is also giving, that's why it became unstable. That's why when the phenol ring, benzene ring of the phenol possesses electron donating group, the acidic strength of phenol decreases, and the acidic strength of phenol that also depends upon the position, substituents position, that is meta phenol is more acidic than the meta substituted phenol, which is more acidic than ortho substituted phenol, and least acidic is your para substituted phenol. And we will discuss some reaction of the OH group of phenol. The phenol react with alcohol and ammonia to form amine. The phenol react with the acetyl chloride, Grignard reagent, and benzoyl chloride to give the respective product. When phenol react with acetyl chloride or acetic anhydride, it gives phenyl acetate, which upon heating with anhydrous ferric chloride, it will be give a orthohydroxy ketone, that is orthohydroxy acetophenol, and this rearrangement is known as Price rearrangement. And we have discussed some neutrophilic substitution reaction of the phenol. The benzene ring of the phenol undergoes electrophilic substitution reaction, means the hydrogen atom of the benzene ring is substituted by an electrophile. Like benzene, it undergoes the electron substitution reaction like your halogenation, nitrogen, sulfonation, field card reaction. Now we will compare the reactivity order of the benzene and the phenol. And the phenol possesses the one electron donor OH group, by which means by the resonance the benzene ring possesses the negative charge, and the negative charge possesses at ortho position and the para position. On the other hand, the benzene ring does not have any negative charge. That's why the phenol can attack or attracted the electrophile very easily as compared to benzene. That's why phenol undergoes electrophilic substitution reaction more easily as compared to benzene. Okay? So, the OH group of the phenol is said to be activating group, means which can activate the benzene ring to attack the electrophile. Activating group, and the electrophile substituted at either ortho position or para position. Due to steric hindrance, the para substituted phenol is a major product as compared to ortho. Okay, student. And last class we discussed about the bromination. The bromination of phenol taking place in bromine water as well as in non-polar solvent carbon disulfide. We will discuss the nitration with concentric acid and sulfuric acid to form 2,4,6-trinitrophenol, which is known as a picric acid, a very strong acid and unstable. It is explosive in nature. When the phenol treated with dilute nitric acid, it gives the mixture of orthonitrophenol and paranitrophenol. Out of these, paranitrophenol is a more major product as compared to orthonitrophenol. And we have discussed the sulfonation. When phenol treated one with dilute sulfuric acid, it forms ortho-hydroxy benzene sulfonic acid and para-hydroxy benzene sulfonic acid. Okay, students, today we will discuss the electron substitute reaction, that is Friedel-Crafts alkylation. We will discuss the Riemann-Tiemann reaction. We will discuss the Kolb-Steinitz reaction. We will discuss today also reduction. Also we will discuss the oxidation and some uses of phenol. Beside this, we will start the ether. Let us start one by one the Friedel-Crafts reaction. You know, Friedel-Crafts reaction are two types. One is called Friedel-Crafts alkylation or Friedel-Crafts acylation. So, in Friedel-Crafts alkylation, an alkyl group is inserted into the benzene ring either at the ortho position or the para position. That is, phenol and methylation with methyl chloride in presence of anhydrous zinc chloride or anhydrous aluminum chloride to form ortho-hydroxytoluene and para-hydroxytoluene, which are known as orthokisol and parakisol. It is called Friedel-Crafts alkylation. And Friedel-Crafts acylation, we will already discuss the phenol react with acetyl chloride or acetic anhydride to form phenyl acetate, which on phase migration or phase rearrangement, it gives corresponding ketone, that ortho-hydroxy acetophenol and para-hydroxy acetophenol. Now, you will discuss only Friedel-Crafts alkylation. Alkylation means you introduce an alkyl group at the ortho and para position of the phenol. That's why you will take the phenol treated with alkyl halide in presence of anhydrous aluminum chloride. So this alkyl group will introduce either ortho position or the para position. It gives the mixture of ortho-alkyl phenol and para-alkyl phenol. This is called ortho-alkyl phenol and this is called para-alkyl phenol. And this reaction known as Friedel-Crafts alkylation. Friedel-Crafts alkylation. Suppose you take the phenol. Suppose you react with methyl bromide in presence of anhydrous aluminum chloride. What product you will get? So you see, R means CH3 group. The CH3 group will be substituted at ortho position and or para position. It will give the two isomers. It will give the what? Two isomers, that is This is called orthokisol and this is called parakisol. And this is known as Fiddlecraft alkylation. Fiddlecraft alkylation means an alkyl group is introduced into the benzene ring. Okay, this is the Fiddlecraft alkylation. That means we can convert the phenol to alkyl substituted phenol. Next comes to another very important reaction for CHSE students, not only CHSE student but also the CBSE student also. The Fiddlecraft reaction alkylation, that is another called Reimer-Tiemann reaction. In Reimer-Tiemann reaction, you can introduce an aldehyde group or carboxylic acid group at a ortho position or para position of the phenol. That's why we can say when introduce the aldehyde group. What is aldehyde group? You can introduce a CH group. What is carboxylic group? COH. We can introduce this aldehyde group or carboxylic acid group at the ortho or para position of the phenol. That's called Reimer-Tiemann reaction. Or you can say formylation of phenol. Formylation means that is introduction of formaldehyde group means CHO aldehyde group. Or carboxylation of phenol, introduce a carboxylic acid group. Okay, but how the reaction is taking place? So the reaction, suppose you take the phenol, this is your phenol. When phenol treated with chloroform, in presence of aqueous sodium hydroxide, or you can say aqueous potassium, any alkali. So a aldehyde group introduced, that is at first it will form a compound like CH2Cl2. This is upon hydrolysis with NaOH, it gives you ONaCHO. This is treated with dilute HCl, it gives you OH, this became CHO. This is called salicylyl dihyde. This is called what? Salicylyl dihyde. You see, an aldehyde group is introduced, CHO group is introduced at the ortho position of the benzene ring in the phenol. That's why it's called formylation. What is called? It is formylation. Here is one type of electrophilic substitution reaction, because hydrogen atom of the benzene ring is substituted by an electrophile, and it is the electrophile is dichlorocarbene. What is the electrophile here? Dichlorocarbene. What is this dichlorocarbene? CCl2 is known as dichlorocarbon. And this dichlorocarbon, how it is produced? The dichlorocarbon produced from this one, that is from chloroform. That is chloroform react with OH minus of sodium hydroxide, and this hydrogen atom acidic nature, and this is base, so it will form CCl3 minus plus water. Now this CCl3 minus react with Na plus, it gives you CCl2, that is dichlorocarbon plus NaC. And you see, this is the deficiency of electron. Deficiency of electron, because the carbon have valency for 1, 2, 1 alone per electron, and they require 2 more electron to complete the octet. That's why it is a deficiency in electron species, that it acts as an electrophile. And this electrophile is substituted at this ortho position. Then it hydrolysis gives you what? Aldehyde group. Okay, student. If ortho position is blocked, suppose orthosaturated phenol suppose you take, that can also undergo the Raymond-Diamond reaction. The electrophile, the CHO group, is substituted at the para position. Make no doubt, it is this is the product, and it is another product also. That is orthohydroxy benzaldehyde, and this is major product. This may be minor product. Okay, so can you convert the phenol to salicylaldehyde? You can convert phenol to what? Salicylaldehyde. You do phenol treated chloroform aqueous potash, and the product is what? Salicylaldehyde, and minor product will be para-hydroxy benzaldehyde. And this is one example of your electrophile, and mechanism of this reaction not included. I have already told the electrophile, and you will same the mechanism follow the halogenous and nitrous in case of benzene. That means benzene ଯେମିତି electron substitution होउची it must ସେମିତି ହିଁ ହେବ. Okay, next come to how the carboxylic acid group introduced. The same way, suppose you change the reagent, the carboxylic acid group also introduced. At what position? The carboxylic acid group will introduce at ortho and para position, that is, if you take CCl4, which is your carbon tetrachloride in presence in place of chloroform, in presence of aqueous sodium hydroxide, it gives you the carboxylic group is substituted at ortho position as well as the para position, and this is known as, what is it? Salicylic acid or orthohydroxy benzoic acid, and this is called para hydroxy benzoic acid. This is also a part of Raymond-Diamond reaction. By the help of Raymond-Diamond reaction, either introduce a carboxylic acid group or you can introduce a aldehyde group. Okay, student, this is all about the Raymond-Diamond reaction. That means in Raymond-Diamond reaction, you can convert the phenol to corresponding, that is aldehyde, or corresponding carboxylic acid. Next come to what you mean by Cox, Kolb, Gametes reaction. The Cobb-Gametes reaction almost same as Raymond-Diamond reaction. So in this case, the phenol first treated with sodium hydroxide, it forms sodium phenoxide, and the sodium phenoxide treated with carbon dioxide gas under pressure. So it forms sodium salicylate. What will happen? This carbon dioxide group will introduce at ortho position. This will introduce at this position. So it gives you sodium salicylate. This gives what? Sodium salicylate means the sodium salt of salicylic acid when treated with this one dilute HCl, it gives you the salicylic acid. Okay, students, and this is the called Cobb-Gametes reaction. In Cobb-Gametes reaction, the phenol get converted into the salicylic acid, and this reaction is called Cobb-Gametes reaction. Are you clear? I have discussed now today Friedel-Crafts alkylation, Raymond-Diamond reaction, which is most important forever, and Cobb-Gametes reaction. Next come to the another one, coupling reaction. That's called diisocoupling reaction or coupling reaction. What is a coupling reaction? The coupling reaction can take place the benzene diazonium chloride with phenol in little alkaline medium at pH 8, that means presence of sodium hydroxide. So this is your this is your benzene diazonium chloride and react with phenol. This is your phenol at pH more than 7. What will happen? And this Cl, this H will combine to form HCl. It is a produce a color compound that is called azodize. Okay, this is called either orange color or red color dyes. Dyes means color, rongo. Dyes means color. Color mane rongo. This is key dye kahwa. This one type of azodize. Azodize can kahwa. This is called your azo group. Due to presence that group only, the compound is color. That's called azodize. And what is the name of this compound? This compound is, this is the, if not there, this is called azobenzene. And what should be there? You can say para-hydroxy azobenzene. Para-hydroxy azobenzene. And this reaction is known as what reaction? Coupling reaction. Okay? In coupling reaction, you form what? A color compound, the azodize. Sometimes this is used for the test of phenol. Okay. Let's come to reduction. Reduction means removal of oxygen. Removal of oxygen or addition of hydrogen. First reduction we will discuss, that is reduction with zinc dust. So when phenol is distilled with distill means what do you mean? Distill means heat. Distill means heat. Distillation means heating. So when the phenol distilled with zinc dust, this will reduce. That is mean this oxygen get removed. So this became H, means this became benzene. This became H or ZNO. This is your benzene. Very important reaction and very much everywhere required for the conversion. But you learn here the OH group of the phenol distilled with zinc dust, it gives you H. That OH became what? H. And this one. Okay, students. Now, when suppose the conversion of phenol to benzene and vice versa, means you convert phenol to benzene and benzene to phenol. Can you now? Can you? I am good, yeah. You see, you just to take the phenol, distill with zinc dust. What will give? It gives you benzene. How can you convert benzene to phenol? Don't think undistilled with this one. No. Another possibility, that is benzene. Do you know method of division of phenol from benzene? So benzene treated with chlorine in presence of anhydrous aluminum chloride, it forms what benzene? This is chlorobenzene. This is fused with NaOH. It gives you sodium phenoxide. This is treated with dilute HCl. It gives you what? This gives you phenol. And this is the conversion of phenol to benzene. And this conversion of benzene to phenol. Another, I will give some other beautiful examples. You know, decarboxylation means? Decarboxylation means loss of carbon dioxide, and decarbonization generally taking place by soda lime. When any carboxylic acid heated with soda lime, the COOH group will become H. That is, the carboxylic acid group is converted into H heat with what? Soda lime. Okay, students. Suppose I will start with OH, COOH. This is your salicylic acid. Suppose the salicylic acid heat with zinc dust, it gives A, and A when heated with soda lime, it gives you B. Okay, students, that is the salicylic acid when heated with zinc dust, the OH will be because it became carboxylic acid. When the carboxylic acid heated with soda lime, it gives you what? Benzene, because COH group became H. Again, if this compound first heated with soda lime, it gives C. C heated with what? Zinc dust. It gives same compound B. Identify A, B, C. So what is A? A is the benzoic acid, B is benzene. Here soda lime, C is phenol, B is benzene. Simply. Okay, can you convert one more? For example, identify ABC. Suppose you start with benzene, it heated with chlorine anhydrous aluminum chloride, it gives A. A is fused with NaOH, then dilute HCl, it gives B. Now B is treated with chloroform plus KOH, or you can say NaOH aqueous, it gives C. C is heated with zinc dust, it gives D. Now our question is, what is ABCD? So, what is ABCD? What is A? Is benzene. A and chlorination, B, benzene and chlorination gives chlorobenzene. Chlorobenzene when fused with and treated HCl, it gives phenol. Phenol when treated chloroform and potassium hydroxide, that is a Raymond-Diamond reaction, that is called salicylaldehyde, orthohydroxybenzaldehyde. When orthohydroxybenzaldehyde heated with zinc dust, the OH group goes vanish, it became benzaldehyde. It gives what? Benzaldehyde. Okay, students. Similarly, so many conversion is there. So this is the reduction of phenol by zinc dust. Next come to catalytic reduction. In catalytic reduction, that is phenol reduced with hydrogen in presence of nickel. You know, it is a very strong reducing agent. It can reduce the double bond. It became, this is your phenol, and this is your cyclohexanol. Okay, this is all about your all about your reduction of phenol. Next come to oxidation. And oxidation, that is addition of oxygen, and oxidation taking place two way. One is called aerial oxidation, when phenol exposed to the air. That is, this is your phenol exposed to the air contains oxygen, and this is your colorless crystals. And an oxidation, it form a compound, that is your benzoquinone, and this is brown in color. And the oxidation taken into the egg, or you can take also chromic acid. In chromic acid, phenol is oxidized to benzoquinone. In CHST, in I think it is 18, the CHST question, name the compound when phenol exposed to the air. Means the compound is your quinone, or you can say benzoquinone. And the phenol can oxidize. Very specific oxidizing agent, that is your K2S2O8, potassium persulfate. And the OH group of ortho and para position get oxidized, so it became OH, and OH. And this is called, do you know what this compound? Dihydroxy compound of phenol, or dihydroxy compound of benzene. This is called catechol, and this is called quinol. And this is the oxidation of phenol. Okay, you next come to the next reaction. Another reaction of phenol, that's called Getamen's reaction. The Getamen reaction almost same as a Raymond-Timon reaction, but the reaction is somewhat different. That is the Getamen's reaction. That is, in Getamen reaction, the phenol treated with HCl in the presence of HCl. Second is your zinc chloride and hydrolysis. It gives a salicylaldehyde. And the aldehyde group introduced at the what position? Ortho position, and this is known as Getamen's reaction. And this Getamen reactions also shown by the benzene. That is, benzene convert to benzaldehyde. Here the phenol convert to salicylaldehyde. So this is all about your reaction of phenol, and very important compound. From the phenol we can also prepare very class of compound. And can you see what the difference between phenol and alcohol? You see, in alcohol, the alkoxide ion is quite unstable. And in alcohol, there is a cleavage of carbon-oxygen bond as well oxygen-hydrogen bond. But in case of phenol, the phenoxide ion, means due to cleavage of oxygen-hydrogen bond, the phenoxide ion is more stable, and there is no chances of breaking up carbon-oxygen bond of phenol, because the bond length is small, less or shorter wavelength means more attractive force. Second, that is a double bond. That is a double bond by resonance. That's why the reaction of the phenol due to the cleavage of oxygen and hydrogen bond only, not a single reaction by cleavage of carbon oxygen bond. And the alcohol never shows any type of substitution reaction, that means electrophilic substitution reaction, but the phenol shows the electrophilic substitution reaction. Due to the electrophilic substitution reaction of phenol, we can prepare a various class of aromatic organic compounds. Aromatic organic compound from phenol. Okay, students, what is the uses now? The uses of phenol, so many, a large, very usual. You know what I mean by antiseptic and disinfectant? What is the difference between antiseptic and disinfectant? You know Dettol, Savlon, these are used as antiseptic. Do you know what antiseptic means? What? आम ऊन है घाई थिबो कि माडवा जाई थिबो ताको जदि हम किछि दिन करला पछे कोन होची सेप्टिक ही होची अथवा पूजिया ही होची पूजा पानी बाहरची ताको बंद करिया पाई you are using some antiseptic, and antiseptic always apply to a living body, whereas disinfectant apply to a non-living body. Bleaching powder is a disinfectant. Pani re bleaching pokeva is a disinfectant. So phenol is used as a antiseptic and used as a disinfectant, and antiseptic used for living organism, this is for non-living organism. So function is same. Here to kill the germ, here to kill the germ. But what is the difference? The difference is it is very low concentration and this is high concentration. You know phenyl, what you use in your household, what is your ব্যবহার করছো phenyl? Phenyl contain phenol, and that apply only in the non-living body. Okay, and Dettol, Sulfone, they are also a part of phenol, a low concentration that is applied to the living body. And phenol is also used for making dyes, ink, and medicines, because it is a starting material for different type of medicine. So there are so many uses of phenol. Few of the dyes means to making color. Ink, you are fond of an ink, that is called phenol. And also used in case of perfume industry, so many things. Okay, students, this is all about your phenol, and I can summarize the phenol. The phenol can be prepared, that is phenol can be prepared from benzene by so many methods. It can also be prepared from benzene diazonium chloride, and the phenol can be converted into aniline, it converted into salicylal, okay, it converted into ortho hydroxy aryl ketone, it is converted into cresol, it converted into salicylyl dehyde, it converted into benzene, it converted into benzoquinone, so many things you can convert this. Okay, student, these are what you are phenol and its some uses, and try to habit to practice. When you practice this, it will be easy, and apply. Not only the practice, we apply. How can you convert this compound to that compound, this compound, that compound, like this. When you convert this, it is easy to remember. Okay. Another is there. It may not be you. Lieberman nitrosamine test. Lieberman test. And this is give the Lieberman test means test for phenol. Lieberman's test, and the Lieberman test for you to test the phenol. Test the phenol means the given sample is phenol or not. Okay, what will you do? Suppose if you take the phenol, this is treated with HNO2 nitrous acid, it gives you para nitrosophenol. This para nitrosophenol rearranged to give quinone. It gives what? Quinone. And this quinone further react with the phenol, means this get lost molecular just get lost molecular. This is lost something. It's just a coupling reaction. This H is there, and this OH and this H get lost molecular water. And this compound, and this OH come here, this became OH, they bonded to nitrogen, nitrogen bonded to the benzene ring, and they bonded to solution. This compound, this is called indophenol. And this indophenol, what color? The indophenol is a red in color. Then you treat it with dilute NaOH, it gives you blue color. This gives what? Blue color. And the blue color due to this H became Na, that became NaO. Students. Double one. So this is called Lieberman test. That is Lieberman test means the phenol treated with nitrous acid, it automatically rearranges and give a what color? Immediately come to indophenol a red color, and red color changes to blue color when water drop of NaOH. This is called Lieberman test. Okay, student, this is all about your phenol, and Next come to the another chapter, that is your ether. What is the ether? Ether it means dialkyl derivative of water. What is water? That is H2O, the 2 hydrogen atom replaced by 2 alkyl group. What will become? R2O, that means ROR. So, this is the alkoxy derivative of alkyl. So, ether is also the alkoxy derivative of alkyl. Means the hydrogen atom of alkyl molecule replaced by the alkoxy group. This became, this would take RO, this. This is your ether, this is your alkyl. Okay, students, and ether are 2 types. And ether containing 2 alkyl group, it is 2 types. That is ether is 2 types. One is called symmetrical and is called unsymmetrical. In symmetrical ether, both the alkyl groups are similar. That is ROR, and examples CH3O CH3, C2H5 O C2H5. But unsymmetrical ether, that is different alkyl groups. 2 different alkyl groups. But there are 2 different alkyl groups. That is the unsymmetrical ether, that is RO, R dash. Examples, that is CH3O, C2H5 or C2H5O, CH2, CH2, CH3. These are 2 different groups. This containing 2 carbon, this containing 3 carbon, 2 different alkyl groups. This is unsymmetrical. If one of the alkyl group is aromatic ring, then you say that is called aromatic ether. That is called what? Aromatic ether. Okay, what is aromatic ether? Aromatic ether means one of the alkyl group is phenyl group. What is phenyl group? Phenyl group means C6H5. This is aromatic ether. For example, this is your phenyl group. O, this is CH3. This is aromatic ether because this is found in phenyl group, and this is known as anisole. This is known as what? Anisole. Okay, students. Just much today. In another next class, we will complete this chapter. The method of preparation of ether, how the ether is prepared, and what are the reactions of ether. And today I will discuss some reaction of phenol. The reaction of phenol means you can discuss about the phenol cut alkylation, Raymond-Timon reaction, Cobb's-Schmidt reaction, Getamen's reaction, and the reduction of phenol. The phenol convert to benzene and oxidation of phenol and some uses. And we have introduced about the ether. Okay students, this much today. You will meet again in next class. Thank you.